Can you see the course page now?
Yes.
Okay, that's good. Now I wanted to emphasize here, a lot of stuff we done here over the last few weeks are already online, okay, in video format, and I have lectured and done so much. For me to keep talking doesn't help you anymore. But you have to go to those videos and on your own time, you go through them slowly, all right?
Yes.
So that way you learn the material. I spend quite a bit of time creating PowerPoint video with narration. I describe what is in the slides, and I have Zoom meetings. Okay, let me show this. If I go to module 1, you can always go back to PowerPoint slide on Introduction to Chemistry. It's a video. Then first class meeting video. That's the PowerPoint slide video with narration. And first class meeting, I gone through that again. Second class meeting video, I finished the first half and the second half of introduction. We gone over it. Then fourth class meeting, third class and fourth class, up to 4 class meetings were happened during this time. Okay. Now let me go to fourth class video. So if I go to fourth class video, it loads up like that. Okay, you got my point. What is the point I'm making? I can go through again same way. It doesn't make sense for me to be a parrot, again and again and again. So you go and watch the video on fourth class meeting, which you probably missed, okay? Do you understand what I...
Yes, sir.
Yeah, I don't want to waste...
No more Zoom meetings at all?
No, Zoom meetings are there because of this hurricane. I couldn't follow it through on the day that we are supposed to meet on last Thursday, remember?
Mm-hmm.
So I have a copy of that video. You go there and go through that, okay? So I'm going to start 5th class period today, okay? Basically what we have covered in chapter 1 is basic material. Now we have to get to the real material on chapter 2, okay? These things are repeated again and again. Going through, you might see certain ideas are again repeated later on the chapter 2, okay? So I'm going to start with chapter 2. But before I do that, I wanted to show you on chapter 2. If I go to chapter 2, I'm going again. Now only couple of, not many students are showing up. I have about 15 maximum I had, but I have about 40 in this class. I need to have them look at these videos. That's why I'm putting it there, okay? It's for you to also ask questions if you are here. I cannot be responsible for people who don't show up, but at least I give them a chance to look at the video, okay? Now, Chapter 1 PowerPoint slides. Do you see the PowerPoint slide video under Module 1?
Yes, sir.
So if you go there, what I'm going to do today is mostly there, but I'm going to go through it myself since you guys are here. So you can go through this. Oh, I'm sorry, this is Chapter 1. I'm sorry, I need to go to chapter. We gone over this. I meant to Chapter 2, not Chapter 1. So Chapter 1 videos are there. Up to class period 4, introduction and Chapter 1, okay? So Chapter 2 is here. The title of the Chapter 2 is The Air We Breathe. There are learning objectives. If you go beneath, go down slowly. You will see, do you see PowerPoint slide Chapter 2 video? If I click on that, now, do you see that I have it there, okay? Until the last slide, I narrate on the slide. But I'm going to go through the slides today a little bit faster. Since you are here, I'm going to help you out, okay?
Do we have any assignments besides the quizzes?
You have assignments to read the end of the chapter problems. Remember, assignment means it's not graded. At the end of the chapter, Module 1, that Chapter 0 is question from introduction. Chapter 1, question from Chapter 1. Chapter 2 is the one that we're going to do today, okay?
Good deal.
Okay, now let's go and I'm not lazy. I do whatever I can do. Okay.
We don't have a problem with that, Dr. Upali. It's fine.
Okay. I'm glad you guys are understanding this idea.
Yes.
Let me get my PowerPoint presentation into here, like real PowerPoint presentation. I'm going to stop the share right now to get my PowerPoint presentation. Can you see my PowerPoint presentation?
Yes.
Yes.
Yes, sir.
Okay, that's good. So let me go through this. I cannot find my cursor.
Oh, we got a test on the 14th.
No, that will be postponed to next week. Okay, what we're going to do is chapter 2. The title is Air We Breathe.
Mm-hmm.
I need to stop the share. I'm kind of not sure how to do this.
Take your time.
Can you see my page now?
Yes.
Okay,
Yes, sir.
I think I worked that out. The chapter 2 is Air We Breathe. We're going to talk about a lot of issues with air pollution. We're going to look at the air is atmosphere, right? We're going to look at in detail the structure of the atmosphere, what pollutants are in there, then how we measure them, the concentrations, how we measure concentration of different components, and chemistry associated with these components, and different types of pollutants like carbon monoxide, ozone, particulate matter. We're going to talk about a lot about them. And we're going to go through EPA standards for air quality. So there are a lot of things you're going to learn from this chapter, okay? So let's see how we go through this. What component make up the air. We're going to learn that. You're going to learn that mostly it's nitrogen and oxygen, and some certain components like carbon dioxide, water, and argon are in there. What impurities are in the atmosphere, how they get there. You're going to learn about that. What are the health implications of inhaling certain impurities? Do you understand there are a lot of problems associated with respiratory system when you breathe particulate matter, certain acidic compounds like sulfur dioxide, nitric oxide, and carbon monoxide, also poisonous gas. Have you heard it before? The air quality. We're going to learn more about them. How we determine the air is safe to breathe. So we have standards for air quality. There's a pollution in indoors and outdoors. Indoor pollution is within a house, within the confined space. Whatever chemicals are released into the indoor space are going to cause you problems. Indoor pollution is different from outdoor pollution. Outdoor pollution is called ambient air. Outdoor is called ambient. The pollutant in the indoor and outdoor are different. So we're going to go through ways how we're going to prevent polluting the atmosphere. Now, how many of you know that the air we breathe is a mixture of several components? Nitrogen, oxygen, major components, and there are small amount of carbon dioxide, water, and argon, and other pollutants like carbon dioxide, carbon monoxide, nitric oxide, and ozone. The ozone is found in the atmosphere close to the Earth's surface. That's produced from vehicular emissions, ozone. But the ozone also found in the upper atmosphere, stratosphere. That is not produced from pollution. It's produced from sunlight hitting the oxygen and creating ozone in the outer atmosphere. That ozone layer protects us from UV light. How many of you heard about that? Are you guys there?
Yes, we are.
Yes, sir.
Okay. How many of you heard of the sentence, stratosphere ozone protect us from UV radiation? I mean, of course, people get melanoma, skin cancer, being
Heard about
exposed. Yes. Luckily, I am a brown guy. I don't have a problem with sunlight. I get darker, and that's one of the advantage we have. Okay, watch the video on what is atmosphere, video on indoor and outdoor pollution. Now, do you understand the air we breathe is a lot of amount? We inhale, exhale. Can you calculate how many liters of air we breathe per day? So I have done here a little bit of the calculation for you. Normally a person takes 25 breaths per minute. Lung capacity is about 6 liters on the average person. then 25 multiplied by 20 per minute and multiplied by 60 multiplied by 24, 25 multiplied by 60 multiplied by 24, how many breaths we take per day, right? So that day, that amount of air is 216,000 liters a day. So that's a lot of air. Okay, can you think of a liter bottle? Coke is a 1 liter bottle, right? So how many of them we are breathing per day? There are a lot of air. So watch the video on what is in the air we breathe. The atmosphere is the one that we are concerned with air. Now the earth crust is solid. This is not atmosphere. Atmosphere is what is above the ground. Now above the ground, there's a thin layer of air which decreases as we go up in the air. There are 5 layers of atmosphere. The one closest to Earth is troposphere. That's where we live. 75% of the air is in the troposphere. Of the whole atmospheric air is in the troposphere. The next layer is stratosphere. Third one is mesosphere, thermosphere, and exosphere. Can you see the picture on the slide?
Yes.
Now the layers are decided by temperature variations. We start with 20 degrees somewhere Celsius around the Earth. When we get to the stratosphere, it becomes minus 52. It got cooler as we go to top of the troposphere. Then we go to the stratosphere. It warms up a little bit to minus 3 Celsius. The boundaries are marked by temperature fluctuation. This is the inflection point. You heard about that word in mathematics? Inflection point, where it increase and decrease, right? Okay. So stratosphere has the ozone layer on them, close to the top of it. Have you seen that white layer in the stratosphere? That's the ozone layer. Mesosphere is the next sphere or layer where the meteorites are falling. Then when they hit the mesosphere, they get burned. So jet planes fly around stratosphere. Satellites are in mesosphere, thermosphere. You see that they're marked. How many layers of atmosphere? How many layers? How many layers are in the atmosphere? 5.
5.
5 layers.
Okay. The
5.
one close. Okay, good. One closest to the Earth is what?
Troposphere.
Glasses on.
That's where we live. That's where a lot of water is there. The rain and the wind, turbulent weather is happening in the troposphere. Okay, you got the basic idea, 5 layers. This is the composition of troposphere. which is 75% of the total atmosphere. Most of it is 78% is nitrogen, 21% is oxygen, and carbon dioxide is 0.041%. Argon is 0.93%. And other gases, pollutant gases like sulfur dioxide, nitric oxide, ozone are in the minority. So you understand basic composition of atmosphere at the troposphere. As you go higher up to the stratosphere, mesosphere, exosphere, the air gets thinner. We cannot breathe. We have to have a spacesuit and gas supply. Now, when you breathe, what happens to the air? What is the major change in the air that we breathe when we exhale? It's the carbon dioxide. No, carbon dioxide is increased 4% from 0.042. And oxygen is the other one. It decreased by 5%. 4%, right? 16 to 21 is 5%. So where does that carbon dioxide come from and the oxygen go in the lungs? We breathe oxygen and use it for respiration. Respiration is a process where food is broken down into carbon dioxide and water. Glucose is broken down into carbon dioxide and water. So the oxygen is required as reactants, and output is carbon dioxide and water. All right? Normally we express percent by volume. The unit, these air percentages are expressed in volume by volume. What is volume by volume mean? Volume of nitrogen divided by total volume of the all other air particles, all the air particles. So like that. Is 78 divided by 100. 100 is the total. 78%. 21 divided by 100. 21%, like that. That's how you say the concentration of component. You have a question? Now, composition of air is given as a fraction first. What is a fraction of something? A mixture is a fraction of parts. It has a whole. Total is a whole. The composition or concentration of mixtures are expressed as a fraction. Fraction is out of decimal place, like one out of decimals of all other components added up to 1. In the solution, where the solute is the minor component and the solution is the major solvent is the major component, that's the fraction is solute over solution. We also use number of particles, like how many oxygen molecules are there, total number of particles of all other items, nitrogen, oxygen, carbon dioxide, like that fraction. You guys already understand what is a percentage is a fraction multiplied by 100, right?
Yes.
Now, since these quantities are air quantities, some of the air pollutants are in very small amount, we have to use another unit, not the percentage, ppm, that make the concentrations in a small number, make up the manageable number. For example, some of the percentage-wise, some pollutants are in like 0.0000 like that. There's a number with so many decimal places. We use 10 to the power to scientific notation to make them manageable. So ppm also use, in place of 100, we multiply by 10 to the 6. So the number become easy to handle. Then even lower concentration of pollutant, we multiply it by 10 to the 9. So fraction multiplied by 10 to the 6 is called ppm. ppb is called fraction multiplied by 10 to the 9. You watch the video on concentration unit, okay? For example, 21% of oxygen in the atmosphere means there are 20 molecules of oxygen, 100 molecules of all other things. That gives you 21%. Ozone is not in a high concentration. Therefore, we use 10 to the 6. Only 0.4 ozone molecules in all other molecules, 100 molecules of all other stuff, all including nitrogen, oxygen, like that. The total is million molecules. So 0.4 divided by 10 to the 1,000 million, 0.4 divided by million is a fraction. Multiply 10 to the 6, it becomes 0.4. How many ozone molecules are there in the atmosphere? 0.4 ppm. When we say ppm, you understand it is very small quantity. It's not like nitrogen or oxygen.
Yes, sir.
So we use,
Yes, sir.
thank you. You guys getting it, huh? Now ppm and ppb, or even smaller. Sulfur dioxide in the air shouldn't exceed 30 ppb. It's very small amount that cause problems. In some countries, carbon monoxide is 8-hour period is 8 ppm. So 8 ppm as a percentage is a very small number with a lot of 9 times 10 to the negative 7. You see that calculation I done here? 9 times 10 to the negative 9 is fraction. Fraction is 9 divided by million. Fraction is 10 to the 9 times 10 to the negative 9. Multiplied by 100. So that fraction is multiplied by 100. It's a very small number. Therefore, we don't use carbon monoxide in percentages. We use it in ppm, right? Exhale air typically contains 78% nitrogen. If you look at that, exhale air 8.7 10 to the 5 ppm. That's a huge number. So numbers are ppm and ppb are like 100 ppm, 50 ppm. You're not using 10,000 ppm because it doesn't serve the purpose. It's a large number. So we use percentage in that case. How many of you got the idea that how we use concentration unit to express the various quantities? Large quantities, we use percentages. For small quantities, we use ppm and ppb, right?
Yes, sir.
So again, I'm trying to tell you, carbon dioxide percentage in the air is 0.402%. That means fraction is that multiplied by that divided by 100, right? That number divided by 100 is 0.00402. Now per 100, so I'm multiplying this by, that's the percentage, per 100. Parts per 100 is what? Percentage, right? Same number. Parts per 1,000, then it become a larger number. Parts per 10,000, it become even larger. Parts per 100,000, it's increased by 10. 100,000, then it become ppm, 10 to the 6, 402. The carbon dioxide is easy to express in ppm than percentage. Do you understand that? It's a manageable number. But carbon dioxide shouldn't be expressed in ppb. Why? We always use the unit to express it in convenient form. I think carbon dioxide in air is easily set as 402 ppm than any other things. Now, you have to get the idea about certain things, the unit of fractions. 1 second in 12 days. Is it convenient to express that in parts per million? 1 second in 12 days. That number has to be around manageable number. How about 1 step in 568-mile journey? What about 5 drops of ink in a 55-gallon barrel of water? Now you can check this. I have done that. So 12 days, I'm kind of trying to calculate 1 second in nearly 12 days. 12 days, how many seconds? 12 times 24, 60, 60. Do you understand what I'm doing? Multiplied by 2 60s and 24. That's a
No.
day.
Yes, sir.
That's the seconds in the day. Then fraction. 1 second divided by that number, 103, is 0.000965. The fraction multiplied by 10 to the 6 becomes 6.65 10 to the negative 7. Then it becomes 0.965 ppm, which is close to 1 ppm, even though, it's very clear. It is suitable to use ppm in that case. Do you understand what I'm saying? ppm are used to conveniently express quantities, concentrations, or fractions. 1 step in a 565-mile journey. 1 step is 2.5 feet. It's a big foot. How many of your foot is 2.5? One step. It's not a foot, it's a step. When you walk, it is more than your step, right? Foot. So 2.5 in 568 mile journey. The conversion factor is 568 multiplied by 5280. That is the feet in a mile. So you get the value 8.34, 10 to the negative 7, when you divide 2.5 that number. So how do you get ppm? 10 to the 6. Then the value become 0.834 ppm. It's close to 1 ppm. It is correct to use ppm in that case. What about the drops of ink in 55-gallon barrel of water? 20 drops is 1 milliliter. 1 gallon is 3785 liters. 20 divided by all the things multiplied to get the number of drops in the 55-gallon. Then the value become multiplied by 10 to the 6. That's the ppm, 1.459. In all these three cases, it is suitable to use ppm. How many of you got the idea now? When we use ppm, when it is in the suitable range for number to be conveniently used, right? Are you guys there?
Yes, sir.
Yes,
we
sir.
still, we
Yes,
still
sir.
here.
Yes, sir.
Okay,
Yes,
okay.
sir.
I'm just checking.
Yes, sir.
I see someone was snoring, you know. I heard. No, I'm just kidding. I'm trying to get it to the bottom of this. Okay. What else in breath? We talk about nitrogen, oxygen, carbon dioxide, water, and argon, and right. In addition to all these things, there are harmful nitrogen oxide, sulfur oxide, particulate matter that is in there. In the picture below, this is China, Beijing, China. I forgot this is a famous place in there. Not Tiananmen Square. There's a building, famous building. Can you see that same picture is in a day where the air pollution hit the area? So maybe a lot of industrial pollution or vehicular pollution, emitting all the things that cause smog. We watched the video on air pollution in Beijing, China. They have less stringent air quality standards. So air is polluted by activities, human activities, mainly through vehicles and industrial emissions. The air also could get polluted by trapping called air inversion. Certain areas where the mountains are, a warm air on the valley trap the cold air. Cold air doesn't go into top. Convection takes place from hot to cold, not cold to hot. So air trap in there. Therefore, it's not recirculated. Then all the emissions from the industry, in vehicles and industries in the urban areas cause pollution. Pollutant often accumulate in the cooler air of an inversion layer. What is air inversion? What is the term air inversion? That's a air trap, cool air trap, because of the top warm air, because of the mountain valleys have that characteristic. So watch the videos on air inversion, air pollution, about the convection current. Now we're going to look at what is the time now?
2:24.
Okay. I will go to 235, okay? We can visualize molecule in air. What kind of molecules are in the air? Carbon dioxide. We use chemical formulas, and water as H2O. So we symbolic form, particulate form. Macroscopic world is, we already talked about it. In the macroscopic world, things are seen in large object as large object. I'm trying to find my mouse here. I couldn't find it. Anyway, what is in the air is molecular compound. They are gases mainly. What are molecular compounds? A molecule formed from non-metals, like sulfur oxygen, sulfur nitrogen, hydrogen oxygen. These are all non-metals considered. There's a chemical bond between two nuclei, oxygen and sulfur, or nitrogen, oxygen, oxygen, hydrogen. On the other hand, ionic compounds are formed when metals and non-metals react to form cation and anion. Like sodium chloride, metal and non-metal. These compounds are solids. They are normally on the surface of the sodium chloride. The molecular compounds are mainly in the air. They are lighter. They are not bonded strongly to each other. What is the difference between molecular and ionic compounds? Compounds between non-metals are molecular compounds. Ionic compounds are metal and non-metals. Do you remember the periodic table has metals and non-metals areas? Sulfur is found in non-metal areas, so is the oxygen. Watch the video on covalent and ionic compounds. So we are particularly interested in molecular structures, molecular compounds. That first one is nitrogen. Second one is hydrogen. Third one is on the first row is carbon monoxide, carbon dioxide, methane. The bottom molecule is carbon and hydrogen, CHO, methane. It's in the natural gas, hydrogen and oxygen. What are these? These are molecular compounds. I'm going to stop after this slide. How do you name molecular compounds? You use prefixes to tell what number of atoms are in there. Sulfur dioxide. How many sulfur molecules are there? First one, we don't say monosulfur dioxide. First one always left as, if it is one, it's left as the name implies. The second one is ide, converted to the I, oxygen, SO2. Oxygen is converted to I, sulfur dioxide, nitrogen dioxide, carbon dioxide, like that. So rules for naming molecular compounds. First, in the formula, SO2, first element is name is kept as it is, sulfur. Second one only change. If second element is sulfur, it becomes sulfide. Hydrogen sulfide, H2S. Hydrogen is kept as it is. Dihydrogen sulfide, dihydrogen, H2S. Oxygen become oxide if it is a second. For example, N2O5, what is the name of that compound? Dinitrogen pentoxide. NO2 is nitrogen dioxide. We don't call it mono nitrogen dioxide. Carbon monoxide is not monocarbon monoxide. This first one is left as it is, if it is one. So you decide whether there's a molecular compound or ionic compound. If it is a molecular compound, non-metal combinations, you use the prefixes. Okay. So you do practice some of this, okay, yourself.
Okay.
2:30. Now you can do me a favor. Go through some of the chapter 2 slides yourself. I have it in the video format. You understand what I'm saying?
Yes.
I'm not imposing anything bad on you or anything, but let me see. How many people